Hello everyone, welcome back. In this video I will discuss the PLC programming using the Logosoft Comfort version 8.1 IDE. IDE stands for the Integrated Development Environment. So the programming languages available in this environment are the functional block and as well as the ladder diagram. So as a kind of change, I will start here by explaining the PLC program according to version 1 solution of the homework 1 using the function block. Okay, so those are actually the blocks responsible for reading the input status of the PLC, and those are special blocks where we can display a message on the PLC screen, so that maybe it's useful for the diagnosis of the PLC status, or maybe interacting with the operator, telling the operator there is kind of faults, maybe the running status of the individual components, and so on and so forth. So this is the OR block, and this is an internal memory flag, and this is an AND block. And you can see here it's actually straightforward. Q stands for the outputs. Here we have Q1, Q2, Q3, and Q4. Q1 is electrically attached to the power contactor K2, and Q2 is attached to K3. Okay, and this is again a message text. And here we have the Q4 attached to the H2 indication lamp, and Q3 is electrically attached to the indication lamp H1. Okay, so this is H1, H2, this is Q3 and Q2, and Q7 is responsible for displaying the fault condition. So now there is a jump. If you remember that the PLC used actually have 4 output relay or 4 output relay terminals, and the Q7 is actually available from within the expansion port. Okay, so we can now have a look at the circuit. As a reminder, this is the circuit breaker, and this is the fuse housing, and this is the service outlet, and this is the power supply with the green indication telling us that the power supply is okay. We have 24 volts DC, and this is the status lint for the local area network, showing that is actually connecting and communicating over the Ethernet cable that is attached between my PC and the PLC. And this is the expansion port, and also we have here a green light indication telling us that the expansion module is already powered and running smoothly. Okay, so this is the protection wire, and this is the Ethernet cable. Those are the power contactors K2 and K3, and their associated overloads. So this is the operator interface. Okay, I will reset it. Okay, and now we would like to transfer the written program. Maybe once we are done with simulating it, we can use the IDE also to simulate it. Okay, so we can just run it, and now we have the keys and we can play with them so that we can experiment the program before downloading it into the PLC, and this is very beneficial whenever the PLC is maybe in a different place and we don't have access to it at the time of programming. Okay, so this is very useful feature of the shown IDE. So now, since I have done the debugging and the programming, and I will just transfer that program directly to the PLC, and from the address book I will choose the IP of the connected PLC and test the connection. It turns out to be okay, and now I can just hit OK. Now, since the PLC was running, now the IDE tells me we need to change its running mode to stop, so we need to press yes, and have a look now at the transfer process between the PLC and the IDE. Now the transfer process is completed, and we need to put the PLC into a run mode. Okay, so by hitting yes, the PLC will be now ready to operate. So now let's give it a try. So by pressing the start push button. Okay, and we can start the first motor, and here we have H1, and due to electrical interlock we are unable to start the second motor, so we need to stop it and start it over, and now we can start the second motor. Notice that whenever the second motor is experiencing an overload, okay, so here we will have the fault indication, and we are unable to start the first motor or the second motor. Okay, so as a matter of fact, now using the version 2 of the solution, here we have embedded the needed modification, which are modifications which are not that much difficult, and we can just now follow the same procedure, and we can download this version to the PLC. Now we test the connection, and we just put it into a stop mode, and now we notice the transfer, and now we can just hit yes, so that the PLC now is ready to operate, and we can also try the operation. So let's start the first motor. Okay, we are unable to start the second one. Okay, stop it, start it over, start the second one. Okay, now let's examine the same situation. Okay, so now here we have fault, and now we can also start the first motor. Okay, so this is the solution according to version 2 of homework 1. Okay, and we need just to stop the system completely. Okay, and we can reset also the overload status. One additional feature of the Logosoft Comfort IDE, we can go online, so we can actually remotely configure and diagnose the status of sorry, this is not the IP. So we can actually test the status of the connected PLC remotely, and we can do so. Now you can see here, those are the inputs, the internal memory flags, as well as the physical outputs. So by actually pressing the first one, we have here the M2 is actually on, and you can see the red wire actually shows the signal is high. And now we can start the first motor by pressing this one, and you can see here we have Q1, which is electrically attached to K2 power contactor, and the Q3 that is electrically attached to the H1 lamp. Okay, and you can just do the same with the second motor. Okay, now regarding the messages displayed on the PLC screen, we can see those messages locally on the PLC screen itself, or we can use what is called the embedded web server. Okay, that is available using the IDE environment, and this series of PLCs that support such a connection. So now by entering the password, we are able to log into the PLC web server, and actually we can see what is really displayed on the PLC screen. So let's run it another time, and now we start the system, and the message displayed on the PLC right now is M1 running. So this is motor 1 is actually running, and we can display another message that is M2 is running. And whenever now we test the overload condition, remember that in the RLC we are unable to tell explicitly that motor 1 or 2 actually is the cause of the overload. However, in this PLC program, we can do so by reading the inputs individually of the overloads. Okay, and that's why they were dealt with as separate inputs rather than being just ORed electrically and entered into the PLC as one input. Okay, so this is the advantages. However, we have to use extra input to have such a privilege. Okay. So now let's examine the overload. Now you can see here M2 is overloaded. Okay, so once we reset it, now the message disappears, and also we can test the motor 1 whether it is having a status of overload by testing the system as shown here. Okay. Moreover, and this is really very critical, so we can access the variables. Okay, and here I would like to simulate a kind of cyber attacks. A kind of cyber attack by which we can actually manipulate and tamper with the status of the outputs. Okay, so key one, remember that key one is connected to the power contactor Q2, so I will put it 1 and just try to see what will happen. Now this is the status of the circuit, and it actually experiences an overload condition. So let's try having operating M1. Okay, we are unable to do anything with that. Okay, so now let's bring it back to the normal operation. So this is motor 1, and let's try having it, and now you see the system is operating abnormally. Okay, and this is actually will cause damage to the system. Hopefully you hear the sound of the contactors. They try to start and stop, and the logic is actually competing with the fault that has been inserted. Okay, so this is very serious. It might cause serious damage. So remember, there's a cost for connectivity and interoperability. That is, you need to have your system not only safe but as well secure. Okay, so whenever you are opening your system to the for the internet, you need to make sure that the connection is secured and no one can tamper with the PLC. And this actually serves as an example of an embedded cyber attack or a false data injection. Okay. So you might have a visit and have a look at my website. This is a set of experimentation or experiments that are related to the automation field. Here we are discussing various aspects of OPC and connectivity and RLC, as well as the PLC programming. Here I have done a handout which discusses the embedded web server. Here you are able to connect a Festo PLC FEC640 PLC via the internet, and you can browse its status and maybe send commands and read status using the web browser. And you need to use what is called the Microsoft Office Publisher, so that you can build up your web page and you can control and monitor the running status of various components, as you can see here. So the link will be added to the description below. So you are encouraged to have a look at it, and maybe if you have some comments, concerns, you may share them with all of us. Okay, so I think this is what I have for now. Shortly maybe I will be coming inshallah back so that I can discuss other issues. I wish you all the best. Good luck. Thank you.